Hi, topic for this session is dynamic allocation. The allocation of memory is done by two ways. First is static, the second is dynamic. Static we have already covered, declaring arrays, variables, primitive data types. Those are all declare memory statically, right? Whenever we whenever we declare a variable or an array, at the time of declaration itself, the memory is fully allocated as per the requirement to them. The second method of allocating memory is called dynamic memory allocation. The problem with the static memory allocation is the amount of data that cannot be predicted beforehand. Suppose I cannot predict what number is user going to input. So I cannot be sure while finding a factorial of a number, the factorial of a number variable should be of what data type, right? Or whenever we are declaring an array, I cannot be sure about the number of inputs user want to give it to me during execution. So I might allocate an array with 5 elements, and during runtime the user wants to give a much bigger value than that, or the number of inputs the user want to give could be 7, 8 or 9. Okay, so we need to have a method through which we can declare the amount of memory to be allocated during runtime. Second issue with it is number of data items keep changing during program. Suppose we have some data about say 1000 people right now. After some time we find that we have more people, like more students or more employees chipped into the system. So we need to keep on increasing the number of students, faculty, or employees, or the number of animals in the forest or anything, right? So data keeps on increasing, right? So we need to have a mechanism through which we can keep increasing the memory required to store that amount of data, right? That those are two basic issues that we face with the static memory allocation. The solution to it is find the maximum possible value of n and create an array of n elements, but this would waste a lot of memory also. Either it will waste or it will give you the memory will expire after an interval of time. For example, we allocate memory for 10 students or say 1 lakh students. Today could be like 20,000 students, but after some time, say 1 year, 2 year or 3 year, the total amount of student will increase, will move above the range of 1 lakh. So at that time the a software or a program will not be able to handle that amount of memory. So that still is not a very rigid solution. So second solution, or the ultimate solution that could be for this particular problem, is dynamic memory allocation or reallocation during runtime as per the requirement. So we should have a mechanism through which we dynamically allocate the memory during runtime, whatever is required, like how much it is required. Okay, and during the phase of time, or during certain interval, if we want to increase the amount of memory to be allocated to store data, we can do it at runtime. We can reallocate or resize the memory during runtime, right? So there are 4 functions that helps us to do dynamic memory allocation. First is malloc. It allocates requested number of bytes and return a pointer to the first byte of the allocated space, right? At the runtime we want say 20 bytes, so we use a function called malloc and get 20 bytes allocated, right? Calloc is allocate space for an array of elements, initializing them to 0 and then return a pointer to the memory, right? The difference between first and second is, first we give the number of bytes, it allocates us that much amount of memory. In second case, we declare the number of bytes we want and number of instances of total bytes we want, right? Suppose I want 4 bytes and I want 10 instances of those 4 bytes. So I can do it by calloc, and which initialize that value to 0 it also, right? That is the difference between malloc and calloc. We'll see that practically as well in the slides to come. Third is free. Now whatever memory we have allocated to the program or the pointer, we need to deallocate it so that it could come into the loop or pool of free memory spaces and can further be used for similar or different processes, right? Last function is reallocation. Now this is really important while you're working with real-time softwares. This helps us to modify the size of previously allocated space. For instance, we have allocated 20 bytes, and after say 5 days or 10 days or 1 year or 2 year, we find that this we have more data than the space allocated, and we want to reallocate or increase the size of the memory from 20 bytes to 50 bytes. So this realloc function is going to help us to do that job, right? Let's start one by one and understand how they work. Right, first is malloc. A block of memory can be allocated using a function called malloc. What it does, it reserves a block of memory of a specified size and return a pointer of type void. So there is no particular data type of the pointer that it returns. It's void type. Void means null. You can typecast it as per a requirement, right? The return pointer can be typecast to any pointer type we want. Suppose we have a pointer, say data type star p. Data type, it means you can have int, float, character, or whatever you want. Then p is equal to data type, whatever data type we have taken in the first or the previous statement. Then the pointer, because we are actually returning a pointer, so we are this particular first bracket is for typecasting the memory that has been allocated. Then we have malloc function, and we give the number of bytes we want it to allocate it for us, right? Okay, let's understand with the help of an example. We have a integer type of pointer p. We allocate a memory. We start from the right hand side for better understanding. We take out the size of integer. Size of operator has been used because it might vary depending upon the operating system. So for instance, it's 4 bytes. So 4 is multiplied by 100. So we are actually trying to allocate memory for 100 integers, to store 100 integers, right? So we have 100 into 4, that is 400 bytes is been allocated using function called malloc, and it returns a void pointer. So void pointer needs to be converted into or to be assigned to an integer pointer. So when we want to convert a void pointer into integer pointer, we need to typecast. So typecasting a pointer to an integer void pointer into integer pointer, we have written int star in front of it, and it allocates the starting address to p, right? A memory space equivalent to 100 times the size of an integer bytes is reserved. The address of the first byte of the allocated memory is assigned to the pointer p of type integer, right? Now the memory is allocated using malloc in the continuous space, right? Malloc always allocate a block of continuous memory. The allocation can fail if sufficient continuous memory space is not available. For example, you're asking for a memory that could be too big or that could be small, but not that much memory is not available in the memory space, right? If it's failed, malloc will return null, and you double add it's in capital itself, right? So we need to, after the allocation, we need to check whether we are looking for some memory. Have we got that memory or not? This is how we do that. We write the whole statement in if and check if it's equal to null. If it's equal to null, we say memory could not be allocated. There was some problem while allocating memory, so we could not get the memory we were looking for, right? Now pointer to an array, how it functions. Your malloc could allocate an array space for you, right? Once the memory is allocated, it can be used with the pointer or with an array notation. We have told you in the previous session itself that array is itself a kind of pointer. It stores the address of the first memory location. The name of the array store the address of the first memory allocation in the array, right? So let's understand with the help of an example. We have int star p, pointer p, n and I. We scanf the value of n. N is the number of bytes number of integers we are looking to allocate. Then we put p is equal to int star typecasting malloc n into size of integer. So we have n number of integer space been allocated to us, and the starting address been assigned to p. For I is equal to 0 less than n plus I, we can scanf using p square bracket, as we do in the case of normal arrays, right? An integer allocated can be accessed by star p plus 1, star p plus 2, and so on till p plus n minus 1. N minus 1 is because we start from 0. So first is star p, that is star p plus 0. Second is star p plus 1, and so on. Or we can use it as p of square bracket 0, 1, 2, and so on. Right? So both the notations are same. We have already discussed this in detail in the previous session as well. Right? So it can also be, in the previous session we haven't used malloc. We are doing the same thing without the malloc function. That was in case of static memory allocation. This is in terms of dynamic memory allocation, how we can access using square bracket also and using the circular bracket also, with that is with reference to address also, and with reference to the subscript value also, or I index value also. Right? So let's see with the help of another full example. Right? We have int in floats pointer height. So what we are trying to do is we're trying to do some mathematical operation on height, which is an array, different set of heights. So float sum is equal to 0, f is equal to average. Printf, we input the number of students whose height we are looking to work with, that is n. So height, we allocate the memory of n number of students, number of float values, because height is in float, and assign it to a pointer height. Right? The input heights for all students are, we input the value for each of those students. Now we have allocated the memory. Now we're looking for data. So data is how we can scan of the data in the same form as we do with the normal array, height square bracket I. Right? Now in the second thing, now we have already declared the memory, input the height of each of the students, kept it into a memory. Right? Now we need to find the sum of all those heights in those continuous memory locations, right, which we allocated using malloc. So we find for I is equal to 0 to n minus 1, we do sum is equal to sum plus height of I. We are doing it like a normal array. The average is equal to total sum we get upon float value n. Right? Average is equal to sum divided by n, which is in float, because we are converting n into float. Sum is already in float, so that we get the average in float. Right? So the average height is equal to, we get it from the previous statement, and we print it in printf, average height is equal to avj. Right? Then we deallocate the memory we allocated using malloc. Right? Now this is really important, deallocation. Right? Allocated blocks should be returned to the system for future use by using the free function. In our computer or a system, there are two set of pools for memory. First is allocated, second is free. Whenever we require a new set of memory, so we get memory from the free pool. Right? And once we have allocated memory using malloc, our memory pointers goes into occupied loop. Right? And if we don't free that memory, or we release that memory, it doesn't come back to free pool, and therefore it will never be used again. Right? It leads to a major problem that is called memory leak. We will come to that also. Syntax for freeing or releasing the memory is free and the pointer, where ptr is a pointer to memory block which has previously created using malloc. Note, we do not have to mention the size of the allocated block. Just mention the pointer, it will automatically see this pointer is going till which memory location. It will deallocate all. Next function is calloc. Calloc also allocates memory like malloc. There is a slight difference, we'll come to that. A block of memory can be allocated using function calloc, reserves a block of memory of specified size. For example, we write integer, size of int, size of float. Size of int is suppose 4 bytes, and the number of such blocks you want. Now this could be handy while we are dealing with something called advanced data structures like structures and all. Right? We'll come to that when we do structures. Right? Okay. So we want 4 bytes, and such blocks, 100 such blocks we are looking for. So we write 100 comma size of integer. We'll come to that with the help of an example, and return a pointer of type void. The return type pointer can be typecast to any pointer type you want. Similarly, the syntax is data type star p is equal to data type typecasting calloc size num, how many such blocks you are looking for, and size of each block, right? So let's see with the help of an example. So we have int star p n comma I scanf. We input the number of blocks we are looking for. So we write calloc n comma size of integer. Size of integer could be 2 or 4, and we are looking for 10, 20 or 30, whatever value is your inputs, such blocks, right? And we scanf it like a normal array and print also like a normal array. We can also print also like a same. We can do scanf and printf like a normal array, or the second syntax could be star p plus I. This we have already done in this previous session, how we can write it in both the forms. Okay, this small catch here, the header file required for all these functions is stdlib.h. So the last function in this particular series is realloc, right? It also allocates a block of memory. In fact, a block of memory can be reallocated or resized using the function realloc. So it's not for allocating memory, it's for reallocating the memory. For example, we have 5 bytes already allocated with a pointer called p, and we want it to be increased to 20, 40 or 50. We want to add more memory. That 5 bytes already been allocated will remain as it is, and additional memory will be allocated. The data on those 5 bytes will remain as it is. It's not going to change by any means, right? So increase the block of memory to a new size, e size, and return a pointer of type void. The return pointer can be typecast to any pointer type we are looking for. Data type p is equal to data type typecasting star realloc void pointer, the old pointer, comma the new size. Okay, let's see with the help of an example. We have float star pointer with nums int I, right? Num is equal to float star calloc 5 comma size of pointer. So we allocated memory for 5 float, storing 5 float values, right? And we stored it in the next line. I is equal to 0 to less than 5, num I is equal to 2.0 into I. So now we want the size of the memory to be increased. So how we can do that? Num is equal to float star, again typecasting to the same memory, and realloc num, the same pointer we want to increase, right? Comma 10 into size of float. Now instead of 5, it will have 10 capability to store 10 float values. An array of 10 floating point value is allocated. The first 5 floats from the old nums are copied as the first 5 float of the new num, and the old nums is released. So we have 5 float memory allocated. We copy the content to a new location where we have allocated for 10, storing 10 float values, 5 as it is, and we deallocate the previous memory allocated, right? This is how realloc functions. Okay, so there are certain drawbacks using those pointers. Let's see them, what they are. Uninitialized pointer might cause segmentation faults. We have declared a pointer, but we have not allocated any memory trait. Just to recall, a pointer size of a pointer is 4 bytes. So like we have integer 4 bytes. For storing the pointers what address. For storing the address, we have 4 bytes allocated, right? We have allocated 4 bytes, but we don't have any value in it, and we are trying to print. It will give us a segmentation fault. A program will halt there. It's a major fault that can halt or withhold the program in the middle of the execution. So you need to be very careful about handling pointers. Second is dynamically allocated block need to be freed explicitly. Explicitly means we need to write a statement, free bracket pointer, right? If explicitly means we need to do it. It should not be done automatically. We talk about primitive data types like int, float. If we allocate memory with int I is equal to 5, we write memory is allocated and deallocated itself. So we don't have to worry about deallocation, right? But in case of this malloc, if you are using any of the functions or allocating memory using dynamic allocation, so we need to free it explicitly, right? If you don't do it, the memory will never come to a free pool, and it will be causing a error called memory leak, right? It could be end star ptr, we allocate some memory and then we return the function, we end the function without freeing ptr, right? So that could lead to the memory leak problem. Pointers are slower than the normal variables because you need to searching and mathematics, going to different pointers and all, so it always takes a additional time, so that's why they are slow. If pointers are updated with incorrect values, it might lead to memory corruption. So we have allocated memory, say for example 5 bytes, and we keep adding the pointer plus 1 2 3 4 and so on, and we move beyond the memory allocated, so it will lead to memory corruption or will crash your memory. Those are 4 basic drawbacks of using a pointer, or other we need to be extra careful while we are using on these 4 parameters while we are using pointers.